Hi students, let's discuss question number 12. Alright, so for question number 12, let's read the question. A particle moves along a straight line and passes through a fixed point O. Okay, its acceleration a meter per second is given by 2t minus 6, where t is a time in seconds. After passing through O, the initial velocity, very important keywords, is 8 meters per second. Assume that motion to the right is positive, alright? Minimum velocity of the particle, very important keywords. Value of k, value of the k. Particle always move to the right after k seconds, and the total distance traveled by particle in the first 4 seconds. So let's discuss part A. Right, so we are given the acceleration. Acceleration means what? It means changes. Changes means different in velocity compared with the changes of the time. Remember the definition for acceleration? So we can just write like this. It's the same meaning. Alright, we interpret acceleration is changes of velocity with respect to time. So dv dt. So we are going to find the velocity. From here, we need to integrate 2t minus 6 and the dt, don't forget, respect the t. Alright, so we have to understand that if we want to find the velocity, we need the time, right? Later, we will use the keywords minimum. Okay, now we integrate first. 2t squared over 2 minus 6t plus c. So if we simplify, we get t squared minus 6t plus c, right? So now, according to the question, initial when t is 0, the particle comes with the velocity 8 meters per second. Don't overlook this one. Don't overlook this. That means when t is 0, if you substitute t0, the velocity is 8 equal to c. So hence, let's rewrite the velocity function in terms of the t without c. Right, so the minimum velocity, the question is asking you, what is the minimum velocity? In order to find minimum velocity, you must know that velocity is minimum if you sketch a function like this. This is a velocity function, it's happened here, minimum, lowest. This is a v, right? So this is a t, right? So if it is the lowest, its dv dt must be 0. That means acceleration 0. Let's go to acceleration and let it 0. So t is 3 seconds, 6 over 2, right? 3 seconds, the velocity will be minimum. Here is 3 seconds. So that means we will find the velocity here, 3 squared minus 6 times the 3 plus 8. So we will get the answer for the velocity is 9 minus 18 plus 8, 9 minus 10. So the velocity minimum is negative 1 meter per second. It means the graph will be something like this. This is the graph, and then this is a v. This is negative 1. Right, this is negative 1 meter per second. This is time. Okay, basically that is a concept. And here is 3. So this is 3 negative 1. So this is minimum value of the v, which is minimum velocity. Alright, so we have solved the minimum velocity. Let's proceed to the next question. It's about the value of k if the particle always move to the right after k seconds. Let's have a look of the shape here. The graph should be something like this graph. Okay, it should be something like this, right? So that means if the particle move to the right, it means that here velocity must be positive, right? So we need to find this and this. That means we must let velocity positive. We must let velocity more than 0. So t squared minus 6t plus 8 more than 0. So if we factorize, we have to read the range of the t. So it's a quadratic function. This is 2, smaller to the left, bigger to the right. So the velocity function is positive here, right? And here. But the time, we always consider the positive value. So the range of the time that we should write is t starting from 0 to 2, less than 2, and then from here is t more than 4, and it will be always positive, right? Okay, because more than 4 onwards, it will be always positive. Less than 4, it will be negative. Well, look at the graph here. It will be negative here, then become positive. So if the question asking for always positive, always, you see the word, the keyword is move to the right, always move to the right after k seconds. So the right k should be 4. If you look at the graph, right? Always positive. It will be, the graph will be always positive here. So k will be more than 4. That means we will consider, let's read the question carefully, after k second, that means after 4 seconds, right? After 4 seconds. After 4, k more than 4. So answer is after 4 seconds for the part B. The particles will always move to the right. Right, that's all my sharing about kinetic linear motion. This is negative 1 meter per second. So answer for number 12, 2t minus 6 equal to 0, k1. And then you integrate the velocity, k1, and find the c. C is 8, right? So then when minimum, let a equal to 0, t is 3. So substitute the 3 into the velocity function, you get negative 1 meter per second. Right, so for part B, you have to let velocity more than 0, and you have to solve it. And because times is always positive, so we choose the time from 0 to 2, and also time must be more than 4. And after 4 seconds, the velocity will be always positive, so k equal to 4.